Okay, welcome to 5.9 Mining. Our goal today is by the end of this lesson you should be able to describe natural resource extraction through mining and describe ecological and economic impacts of natural resource extraction through mining. So first we're going to cover some important terms about mining, which is the collection of natural resources from the earth. So we're going to start over here. So we're going to talk a lot about the word ore, which is commercially valuable deposits of concentrated minerals that can be harvested and used as a raw material. So examples of that are iron ore. We're also going to talk about metals, which are elements that conduct electricity, heat, and have structural properties for building. Other important mining terms is the term reserve, which is the known amount of a resource left. It's usually measured in years left of extraction. So for example, some of our metals have about 100 to 200 years left. Iron has about 120 years of extraction left. Some things like zinc or gold are down to 20 years of extraction left. You're going to hear terms that relate to the waste parts of mining, such as overburden, and this is the soil or vegetation or rocks that are removed to get to the ore deposits below. And we have tailings and slag, and these are the leftover waste materials that are separated from the valuable metals or minerals within the ore. The tailings are often stored in ponds at the mining sites, so if we look here, this is a tailings pond to collect those waste products, but you're also going to hear a term called gangue, right here, gangue, which is the parts of the ore that you can't get profit off of. So it's the non-profitable parts of the ore, and then the tailings are all of those other things that you have to remove to get to the ore. So these impurities, the sand in the soil, would be considered tailings, and the gangue is the less profitable or not profitable part of the ore. So we're going to start with talking about surface mining. Surface mining is the removal of overburden, so all that vegetation, rocks, and sand and soil above the deposit, to access ore that's near the surface. So there's different types of surface mining. There's open pit mining, strip mining, mountaintop removal, and placer mines. What's tricky about surface mining is that as you do more surface mining, these ores become more scarce. And as they become more scarce, you then have to move deeper and deeper underground and resort to subsurface mining to reach those deposits. Problems with surface mining is that it leads to topsoil erosion because you're physically removing the vegetation in the soil, habitat loss, increased stream turbidity. We know that when you remove vegetation and you expose the bare soil, that it leads to stream turbidity from erosion. It's going to put those sediments into nearby bodies of water. And then it also increases particulate matter in the air from the actual processing and harvesting of the ore. So here's some examples of the different types of mining. We have strip mining here. We've got mountaintop removal. This is open pit mining, and then the placer mining, such as gold mining. Mountaintop removal is considered especially damaging to landscapes and habitats and streams because you're taking all of that material that's on top of your ore deposit and pushing it downhill. We also have subsurface mining, which is below ground. So often a vertical shaft is drilled down into the ground and an elevator, so we see down here, we get an elevator that carries workers and transports resources in and out. Oftentimes this is used for coal, and as we deplete our surface coal deposits, we have to resort more towards subsurface mining. Problems with subsurface mining is it has a lot of risks. And you can see here, this was posted on November 21st, 2020, that they're searching for a lost miner trapped in a zinc mine in South Africa. Problems with subsurface mining is that it risks that you could have poor ventilation leading to toxic gas exposure, canary in a mine shaft. There's mine shaft collapses, injuries from falling rocks. Who mine are at risk of lung cancers. There's asbestos, there's fires, there's explosions. And as a result, economically speaking, this results in higher costs due to high insurance and healthcare costs for workers due to the risks. Mining comes with a lot of environmental risks. We see here that rainwater carries sulfuric acid into nearby streams or infiltrates the groundwater. The acid can lower the pH of water, making toxic metals like mercury and aluminum more soluble in water. This eventually will kill your aquatic organisms. Coal mining naturally releases methane gas from the rock found around the coal. So this is ventilated out of mines to prevent those explosions. But even after you close a mine, it will continue to seep out. We know that methane is a greenhouse gas, and so this is going to lead to climate change. As I mentioned earlier, there's particulate matter. The particulate matter, especially in coal mining, releases soot and particulates that can irritate the lungs, particularly people who are already susceptible to lung irritation. We also have what's called acid mine drainage, and this is because you're exposing pyrite, which naturally contains sulfur. And when the rainwater from abandoned mines and tunnels mixes with this pyrite, it forms sulfuric acid. So the pyrite plus the oxygen in the water gives us this ferrous, iron, and sulfuric acid, and it's going to flush out of your mind and eventually end up in our water sources and leads to dead aquatic life. In some places in the world, they also use a cyanide solution to leach gold out of rocks, and this cyanide solution can also get into our bodies of water. But it's not all bad. We also have what's called mine reclamation. So this is where you're reclaiming a mine and trying to turn it into something similar to what it looked like before. So it's the process of restoring land to its original state after mining has finished. So here's an example, as it was when it was a mine, as it is now. There's 4 things you must do to reclaim a mine, which is fill all empty mine shafts and holes. Those are kind of a hazard. You're going to restore original contours of the land, so you're going to try to make it look like it did before. You're going to have to return the topsoils, but you're going to have to remove the acids, the metals, and those tailings, and then replant native plants to restore the community as close to original as possible. So to summarize, our goal was to describe natural resource extraction through mining. So we talked about surface mining and subsurface mining, and then describe the ecological and economic impacts of natural resource extraction through mining. So we talked about subsurface mining having more economic impacts because it's more expensive with miner health and safety, and the various ecological impacts such as increased stream turbidity, greenhouse gas emissions, particulate matter emissions, and acid mine drainage.